Okay, so 1.4, applications of set theory. Investigate the math. Rachel surveyed grade 12 students about how they communicated with friends over the previous week. 60, that's called on a cell phone. You consider it called, like talked. That's not going to happen. Only 76% text, so these numbers can't be real, but whatever. 34% use social networking site, 56% use cell phone and text, 18% call and text. So we've got three things going on, right? We've got cell phone, texting, not that that happens without a cell phone, but cell phone, texting, and social networking. And the question is, what percent of students use at least one of these three forms of communication? So what we're going to do is we've got three things, right? So we are going to construct a three-circle Venn diagram. I don't know where we're going to construct that, but I guess we'll do it here. I should at least make it look like what the, yeah, okay. So cell phone, texting, social networking, and there's the universe. So the universe consists of 100% of the students, right? All the students. 66% called on a cell phone. Now you notice the cell phone circle is split into 1, 2, 3, 4 regions, right? The texting circle is split into 1, 2, 3, 4 regions. The social networking circle is split into 1, 2, 3, 4 regions, right? So we got these numbers. Now, ultimately, when we are done with cell phones, if we add up the 4 regions in the cell phone circle, it has to add up to 66%. So there's no way that I can put a number down anywhere in the cell phone circle yet. All I know is that all 4 of them have to add up to 66. I can't write anything in the texting because I know there are 4 of them and they have to add up to 76. And I can't put anything in the social networking. Again, there are 4 of them, but it's got to add up to 34. So what's the most restrictive area in this diagram, right? And it's the middle, right? And so what's the middle? What does that represent if we're talking about cell phone, texting, and social networking? All 3. So 12% used all 3 forms. So we're going to put 12 in the middle. Okay. Now, we start to go with the ands. So this little football shape here, right, this oval, is texting and social networking. So 19% texted and used a social networking site. So what number goes in here? All right, what's the total of people that texted and used social networking? 19. And how many of those have we accounted for already? 12. So how many are in here? 7. Okay, so here's the really important distinction in this idea, right? This little football here is texting and social networking. Part of this is texting, social networking, and cell phone. Okay? So if I say 19% texted and used a social networking site, that 19% includes the 12 that did all 3, right? Because if you're doing all 3, then you are doing texting and social networking. The 7 only did texting and social networking, okay? So 19 texted and used a social networking site, 7% only texted and used social network but did not use a cell phone, right? So of that 19, 7 only. So, you know, the football shape is here, is the intersection between texting and social networking. Okay, so if I say texting and social, I'm including both of these. If I say only texted and used social networking, then we're talking this little chunk of that site, right, of this oval, just this piece. So if I say 18% called on a cell phone and used social networking, so cell phone, what goes in here? 6. And if I say 56% called on a cell phone and texted, what goes in here? You expect us to subtract 12 from 56? 44. Okay? So that's how we fill one of these guys in, right? We start with all three, because that's the most restrictive. So we do the all three. This is number one, right? Number one, that's the first thing we did. This is number two, right? But it's 19 minus 12, which is 7. That's what gets filled in, okay? So I need, what you're saying is I need 19 in here, but I already got 12, so I put 7 in there. So you start off with the all three, and then you go to the ands. Okay? Now remember, just like yesterday, and is the intersection. Okay? And then just treat it as a two, so you sort of forget about the cell phone circle here, right? We're just dealing with these guys. This is the and, texting and social networking. Okay, now we can go to here. 66% called on a cell phone, but how many do we have in the cell phone circle? 44. Plus 12 is 56, plus 6 is 62. So how many only called on a cell phone? 4, right? So there has to be 66 in this circle, but we've got 62, so it's got to be 4. Okay, 76% texted. Well, what have we got? We got 56, 63. So how many only texted? 13. And like it doesn't say that there's people who did neither, right? So we can either say, well, it's all got to add up to 100, but we don't know if there's 34% use social networking. We've got 6 plus 12 is 18, 25. So how many only use social networking? 9. Okay, now we can add all these up, right? What's this at? So we got like 48, 50, 60, 66, 73, 76, 86, 95. How many did neither? None of the above. So there are 5% that did none of the above. Okay, now I'm really hoping this matches up with the answer they have if we scroll down and all of that. But so that's how this is filled in, right? So that if we look at this, right, the 4 is only the cell phone and none of the others. The 13 is only texted. It did nothing else, right? So if in there it said 13 texted and did nothing else, then you know the 13 goes in this area, right? There's no overlap between that. It's just this. 9 only used social networking and none of the others. Okay? 19 texted and used social networking. 7 only texted and used social networking and did not use a cell phone, right? That's what the 7. 6 only did cell phone and social networking but did not text. 44 only used their cell phone or texted but did not use social networking. Okay? 56 used a cell phone and texted. Okay. 18 cell phone and social network and so on. All right, so then there's this, and then, oh, okay, good. They didn't give an answer. So then mine's right. They talk about this principle of inclusion and exclusion. Do you want to use this formula? It's an easy formula. It's not bad, right? So it says the number who used the union of S and T and C, the union of the social networking, right, is the number who used a social network. Okay, so does everybody have the book open in front? We can fill in the numbers. What are the number that used a social network? They give it to you, right? Somewhere in the book. It's in the question. It's not. The question says 34% use a social network or whatever. What's the number? Oh my God, they don't know how to read. I'm gonna get a book. We don't know what you're talking about.
Everything added together.
1.4.
Oh.
Going back to the original. So the original question said 34% used a social networking. 34. It said 76% texted. 76. It said 66 called on a cell phone. We can't add those up. That's way more than 100%, right?
Yeah.
So the problem is, when we talk about people that texted, we're talking about people that texted, but they also may have, so if we count people that texted 76, and you look back here, with this 76 that are in the texting circle, we're talking about, well, they texted, or they texted and they used a cell phone, or they used all three, or they texted and used social networking, right? So the 76 people, we're counting a whole pile of people twice, right? We're counting all 76. We're going to count these guys as the 44 here will be counted in the texting and the cell phone, right? Because they're in both circles. Okay, so the problem is we're counting all of these areas twice, so we need to start subtracting off. So we subtract off the intersection, right? So this is and, right? This is or, social or text or cell phone. This is and, so it's social and telephones. That was 18. No, sorry, social and texting and social, 19. This is social and cell phone, 56, called on it, okay, that's 56, called on a cell phone texting. 19 texted, that's 19, we got that. 12 used, okay, wait, so, where the heck are you? 30, 50, where's social and cell phone? Text. Oh, 18. 18. Okay, so these numbers are all pulled off of page 39. If you were actually looking in the book at the question, that's where these numbers are. So what we're saying is, look, if I want to know, right, this is what we got as 95. Right? This is what we got as 95. How did we get 95? Well, we filled this all in, and then we just added all these guys up. Okay. So what the book is saying is, you know what, you could do this using a formula. You could take the 76, but you got to subtract this away, and you got to subtract this away. You could take the, whatever's in here, this is social network, 30, if you take these 34, but you got to take away this and this, right? Because you count them twice. Now the problem is if you do everything that they've done, you'll end up subtracting the 12 off one too many times. So that's why in the formula, you have to add the 12 back on. Okay, everybody's got a calculator. It can go 34 plus 76 plus 66 minus 19 minus 18 minus 56 plus 12, and then hit enter and see what you get. So do I, but I want somebody to actually say it. See, I did it and I got. No, 95. Sarah says 95, right? Okay, do you want to do this?
No.
No. Yeah, but, so here's your choice, right? You can memorize that formula and say, okay, so if I want to do this, I've got to add this plus this plus this, but then I got to subtract off these intersections. Oh, but wait, then I subtracted off the middle 3 times, right? I subtracted the middle off too many times, so I got to add it back in once. Or you can just do what we did, filling in the diagram. And then you can just add up all the numbers in the diagram once and say the answer is 95, and I didn't have to go through this formula, which I'm likely going to make a mistake if I'm trying to memorize it and do it.
What if there's like a form where they gave you the formula?
They don't give you the formula. They won't give you the formula. You will get these formulas. There's no 3 circle stuff on this. Okay? So, here's the deal. You do not want to do this. You want to stay away from this. If I assigned a question that's got that, just don't do it, right? We don't need to use these formulas, whether it's a 2-circle Venn diagram or a 3-circle, right? What we want to do is just go through and fill it in. Okay? If we fill it in, then we can answer any of the questions that they could ask. So this one here, right? This is going to say using the principle of inclusion and exclusion. In other words, using those formulas, right? We're not going to do that. We're going to do this. Use the following clues to answer the questions below. So we got dogs, cats, and birds. Okay, dogs, cats, birds. We have information. 28 children have a dog, a cat, or a bird. 13 children have a dog. Okay, can I fill in any numbers yet? No, right? 13 children have a cat. Can't do it. 13 children have a bird, right? All it means is I need to know that there are 13 in each of those circles, but I can't fill in any. 4 children have only blah, blah, blah. Okay, is there anything where it's got all 3?
No.
Okay, so it says 4 children only have a dog and a cat, 3 children only have a dog and a bird, 2 children, no child has 2 of each type of pet. Okay, so they can only have like 1 of each or whatever. Okay, so does anybody have all 3? Only a dog and a cat, only a dog and a bird. Okay, so nobody has all 3. So we put a 0 in here. Okay, nobody has all 3. 4 children only have a cat and a dog. Okay, so remember, this 4, that's the only, that little slice that I just put the 4 in, that's only cat and dog, right? Or cat and dog but not bird, right? Because this is cat, dog, and bird. So this is cat and dog but not bird, or only cat and dog. 2 children have only cat and bird. 3 children only have dog and bird. Okay, 13 children have, we got 7 already. So that's 6. We got 6 here, so that's 7. We got 5 here, so that's 8. And now we can answer any of the questions that they have, and we're not going to be writing horrendous formulas that have all kinds of weird symbols in them that we're going to mess up because they don't give us formula. So, how many children have a cat, a dog, and a bird?
0.
None. How many children have only one pet?
6 plus 7. Oh,
Yeah, 6 plus 7 plus 8. 21. 21 have only one pet. All right. So now we can go look at whoever's solution, right? So Haley's solution using the principle of inclusion and exclusion, right? This is using all the formulas. I defined this. I don't know what the x is there. I've got this really complicated formula. Oh wait, apparently one child has. Okay, so now we've got something messed up here. Now we got to back up. One child has. Oh wait, sorry. So there's 28 children, right? Okay, so we don't know. We can't put anything in here yet, but we can put the 2, the 3, and the 4. All right, so we can't. All right, let's just wipe this out. Start over. Oh, this is doing math. You screw up and you start over again. Don't do pen. I don't know why you guys would use a pen.
There's 28 kids.
Yeah, I ignored one piece of information, which was there are 28 children. Okay, so we start this off. 2 children have cat and bird. We put a 2 there. 3 children have dog and bird. We put a 3 there. 4 children have dog and cat. We put a 4 there. Okay, there are 13 children that have a dog. So we'll put an X here. So we'll say 4 plus 3 plus X plus, let's say, D is equal to 13, right? So we'll put a little D there. That's only a dog, right? So here we'll put a little C, and here we'll put a little B. Okay, so we can say 4 plus X plus 2 plus little c. Whoops, put that where we can read it. 4 plus X plus 2 plus c is, well, let's simplify this a little bit here. So 7 plus X plus D is equal to 13. So here we've got 4 plus X plus 2 plus C is equal to 13. So 6 plus X plus C is 13. And we've got the bird, so 3 plus 2 plus X plus B is equal to 13. So 5 plus X plus B is equal to 13. And what else do we know? We know that 3, 4, 2, right? So 7. So 9 plus B plus C plus D plus X is equal to 28, right? So 9 plus B plus C plus D plus X is 28, right? Because there's 28 kids in total, right? And it's going to say each child has, 28 children have a dog, a cat, or a bird, right? So there's 28 that have at least one of each. So in the universe, there's 28, and there's nobody outside of here. Okay, so that means that B plus C plus D plus X is equal to 19, right? 28 minus 9. And then we've got all this information, right? So this can be b plus x is equal to 8. Just simplifying this. This is x plus c is equal to 7, and this is x plus d is equal to 6. Okay. Wow, I'm just forgetting I did this the first time, right? That's just a bet. Yeah, now that we know the answer is 1, why don't we put a 1 there? No, we got to get the 1 all on its own.
Are you just like subtracted it? Like
What?
28 minus 27, then you know the 1 goes in the middle.
No, because there was that assumption that this added up to, oh, are you saying we had 1 more than we needed?
Yeah, you had 1 less than you needed.
Oh.
So when you just shove the 1 in the middle?
I suppose. Let's just back up a bit. But, okay. But we could do this. We shouldn't have done that in the first place, right? So we know that b plus x, that these two guys added together make 8, and these two guys make 7, and these two guys, and we also know that, what do we got? B plus c plus d plus x is 19. So we can take these guys and add them all together, right? And we're going to end up with 3x plus, it runs out of ink too in the middle of it.
Virtually.
3, yeah, I know. Virtually plus b plus c plus d is equal to, what do we got here, 21? Okay, and we got b plus c plus d plus x. Okay, b plus c plus d plus x is 19, which means, get rid of these guys, we've got 2x is equal to 2, and x is 1. Yay, so there we go. So that's a 1, and then that's a 8, that's a 5, and then that's a 6, 7, that's a 6, and then that's a 6, that's a 7. Okay, there you go. Then you could do all of that without using this formula. Okay, so there's one child that has 3 different pets. Hang on. Tech support to the home. Yes. All right, correcting errors that, well, we already did this. Correcting errors that involve sets. All right, let's try this one. Shannon's High School starts a campaign to encourage students to use green transportation for traveling to and from school. At the end of first semester, Shannon's class surveys the 750 students in the school to see if the campaign is working, and they obtained these results. 370 use public transit, 100 students both cycle and use public transit, 80 students walk and use public transit, 35 students walk and cycle, 20 students walk, cycle, and use public transit, 445 students cycle or use public transit, 265 walk or cycle. How many students use green transportation? Yeah, that's not green.
But
Driving is not green.
I think at least one person would drive.
Unless you're driving an electric car.
No, electric skates are good.
If you're flying, that's clean.
All right, so instead of worrying about the error that somebody made, because I already made one of those and we fixed it, let's just take this and see, can we do this diagram? Okay, do we have all 3?
No.
20 students walk, cycle, and use public transit. So we got all 3. Where are we putting the 20? In the middle. This needs to get bigger. Actually, you know what? Let's just open up a... No, I was thinking another notebook file, but hang on, I think I can do that. You can open up a blank notebook file, and then we'll just... So you have to give me the numbers, because I won't have this here. But we'll do it on a bigger... All right, so what you want to do is get out just on your paper, just draw this diagram, which eventually is going to come up, and then just say, number 1, we're going to put the 20 in the middle, okay? Because you want to know what order you did this in. Otherwise, you just end up with a diagram, there's all these numbers on it, and it's like, if you go back to look at it, it's like, well, how did I fill that in? Like, I don't know how I got all these different numbers. I'm going to pause. The big takeaway from today is just, what are each of these regions, right? And how do we handle the numbers that are there. Okay, so that's what we're looking for, the big takeaway. All right, so we start with the all three, right? So 20 students walk, cycle. So number one, we have 20 students that walk, cycle, and use public transit. So there's 20. Okay, now we look for the ands. 35 walk and cycle. Okay, so we go back here, walk and cycle. What goes in here? A number. Which number?
I don't really know the correct number.
35 walk and cycle. What goes here? 15. Now, they could also have said 15 only walk and cycle. Okay? So, this thing here, 35, is walk and cycle. The 15 is only walk and cycle. Right? So that was the last one. Only have a dog and a bird. Right? That's the only. So this, and this is only. Okay, so now we go back here. We got more onlys. So 80 students walk and use public transit. So what goes here? 60. Okay, and so that was next. That was number 3. 100 students cycle and use public transit. Okay, cycle, so what goes here? 80. Okay, any questions so far? So we've done the all three, and then we go and we do the ands. But be aware, if they said only, they would have used the number 15, right? So these questions here could have been phrased instead as 15 students only walk and cycle, 60 students only walk and use public transit, and 80 students only cycle and use public transit, and we'd be looking at the exact same diagram. Okay, 370 use public transit. Okay, so we've got 160. So that means that 210, that did it, thanks. It's like long distance tech support. So 210 only used public transit. Okay, so that was number 5. What else do we have? 445 students cycle or use public transit. 445 cycle or use public transit. So that means this, and this have to add up to 445. Okay, so cycle or use public transit means it's in the cycle circle or the public transit circle or both. Okay, so we basically just have to add up all these numbers. There's 100, 310, 370, 385, and then say we need to have 445. So that's 60. Okay, so if we add up all of those numbers that are on the board right now, it should add up to 445 because that's in the cycle circle or the public transit circle. Right? So if I say cycle or public transit, we're talking about all of these plus all of, but don't add anything up twice, right? That's where we get the complicated formulas. Just say, okay, I'm just going to add each of these guys together once. Okay, and that should be 445. Hopefully it is. So that was, we did this one, 265 students walk or cycle. Okay, walk or cycle. So that means forget about this. These numbers and this have to add up to, what was it, 265? Okay, so what do we got? We've got 120, 200, 220, 235. How many did I need? 265. What did I just say that added up to? 235. We need two, so we need 30. Okay, so that's filled in all of the information that's in here. So how many students? Now we surveyed 750 students, right? So that was what, number 7. We surveyed 7, so we need to know how many are outside of this, right? We need to add all of these guys together. All right, what do we got? 120, 200, 410, 430, 460, 475. Okay, and what does it add up to? 750. So we'll need 75, 275. So 275 are out here. Okay. I'm just going to look at the book. Let's see if I messed up yet another example, in which case I'm just going to kill this recording and pretend it never happened. Numbers in my Venn diagram seem reasonable. I don't think they actually answered it as to how many do neither. Okay, 210, 60, 20, 80, 30, and walk only, 15, 20, 60, and 60 there, yeah. So this is filled in the same as the one in the book. All right, but they don't say anything about how many used neither, but I added that in, I guess. All right, so good to go. Okay, so start with the all three. Then very carefully see when they're talking about and. Does it include the 20 or not, right? So just the word and will include these 20, and only means you're just dealing with this number here. Okay, you don't worry about the 20 if it says and only do this. So if it says 100 students cycle and use public transit, you have to take away the 20 that you already have. If it says, this could have said 80 only cycle and use public transit. Okay, and then there's Alberto's solution and not worried about the errors that somebody made. Okay, in summary, set theory is used for solving many types of problems, including internet searches, database queries, data analyses, games, and puzzles. Games and puzzles, right? There's that unit. To represent three intersecting sets with the Venn diagram, use three intersecting circles, for example, in the following Venn diagram. So A intersect B intersect C is represented by region H, right? This is the intersection of all three. Remember, upside down U is intersection, right side up U is union. A intersect B is represented by E plus H. Okay, if we say only A intersect B, then we're talking about region E. Right? If it's only the intersection of A and B, right? Not including the intersection of A, B, and C. A intersect C is represented by G. Only A and C is G. B intersect C is represented by this. Only B and C is little I. Each region of the Venn diagram contains elements that occur only in that particular region. Don't worry about this formula. It's not on the formula sheet. You don't have to know it. You won't be given it. You won't be asked any questions that deal with it. Trust me on that one. Need to know. You can use concepts related to sets to search for websites on the internet. Put an exact phrase in quotation marks. Connect the words or phrases with and. Search for sites that contain both. The word and represents the intersection. So if you want to narrow a search down on the internet, you put the word and, right? So it's got to have this and that. It's got to belong to both sets. Connect words or phrases with or to search for sites that contain either one word or both, right? So if you use or, you'll get one of the words or both of the words. You'll return more, right? And is going to be more restrictive. It's got, let's say it has to have both of these characteristics, or is going to be more broad. It's going to be more open, right? Because you can have one or the other, or both. When solving a puzzle or problem, it's often wise to visualize the problem, identify which sets are defined by the context, then identify how the sets overlap. Finally, identify regions of overlap that are of interest, right? Blah, blah, blah. Okay, big takeaway. If we just use the word and, A and B, we are talking about these two. Only A and B, we're just talking about this, right? So you could think of it as A and B, but not C. So we could write that A and B, not C. Okay. Oh, wait, actually, there's one more thing we need to cover off. Just give me a sec. So let's say we have to shade in the region that's represented by A union B prime intersecting C. Okay, so we know, all right, so we're going to start with the three-circle Venn diagram with A, B, and C. So let's start with, and what you want to do is just do this in a few steps, right? So we've got A, B, C. So we want to start with A union B. Okay, so what's A union B? If I'm going to shade A union B, what do I shade? Okay, so we'll start here. A union B means shade everything that's in A. And everything that's in B, right? So A union B just means A or B, right? It's in A or it's in B or it's in both. Okay? So we're going to do that first, right? We're going to shade it. We're going to do this in like 3 steps because now we're going to do A union B prime, right? If we want to see what this is, we don't want to try it all at once, right? So that's A union B. So the next step is to do A, B, C, A, C. So now we do A union B prime. So what do I shade? Yeah, the opposite, right? So basically I'm shading everything that isn't what I shaded the first time. So that's all of the outside as well as anything that's just C, right? So this region here is just C, only C, nothing else, right? Only C, so I want to shade only C and all of the outside. Okay, so that's A union B prime, and now I want that to intersect with C. So what's the final thing that I'm going to shade? Okay, so this will be A union B prime intersect with C. So I want this intersecting with C. What do I shade? Only C, right? Just this part here. So where does all of this shaded region intersect with C? Just this. Okay, so another way to say that would be to say only C, right? Just C. Not C and A, not C and B, not A, B, and C, just C and nothing else. I want to pause this and try one thing. Okay, and I saw this on the field test or something, not this particular one, but stuff like this, right? So the idea is let's shade in B prime intersecting with the intersection of A and C. So again, we should do this in a few steps, right? So where do we start? What should we do first?
Color in
A intersects C, right? Because it's brackets, right? And brackets say do me first, right? It's just order of operations. So we want the intersection of A and C. So what am I going to shade?
all of A and all of C.
Nope. I want the intersection.
But wait, no. Right?
Well, this is A intersect C. Okay, so we just want to go one step at a time. Right? So that's A intersect C, right? So we do the brackets first, just like doing an order of operations. Okay, now we want to say where does everything that is not B intersect with what we've already drawn here? So now what ends up getting shaded? Okay, so we've got A intersect C. We now want to intersect that, so it means it's got to be part of what's already shaded. What part of already shaded do we want to shade? What's the language that we use? So I don't want the B, right? So not B, so I can't have this because that's part of B. So what I can have is just this. Okay, so this is really just only A and C. Okay. It's only A and C. So the first part was, where's the intersection of A and C? Okay, that includes part of B, right? The middle part is A, B, and C. We don't want B, right? We want the intersection of everything that isn't B. Where does it intersect? So intersect, union means we're going to be shading more, right? It's like this and we're shading more regions, and intersection is more restrictive, right? It takes it down. So this is really just equivalent to only A and C, right? Only the intersection of A and C, not B. Okay, so you will see that stuff. Or you may see that stuff. And I wrote some questions for field test along these lines, right, of what region is shaded. So your best bet is just to take it one step at a time. It'll probably be like 2 steps. You just shade the first part and then shade the second part, and then just worry about what it is that's left. Okay, that should do it. Oh. So we're going to start this one with the brackets. We're going to go the union of B and C. A, B, C. A, B, C. So the union of B and C, what am I shading? All of circle B and all of circle C. Okay, B union C. Yep. Well, for now, we're just doing B union C, right? We're just going to do one step at a time. So, now, what we want is to take everything that's not A. So, what I might actually do is just go in here and say, let's do everything that's not A. So if we shade this, then what we're looking at for our third one is I want to take whatever's here and subtract from it whatever's here. Okay, so I think that's really the best way to do this is to do, okay, let's look at this. Let's look at everything that isn't A. Okay, so what's everything that isn't A? It's going to be anything outside of A. So it's basically the entire diagram is shaded except for what's inside circle A. So it's going to include this, all of this, right? I mean, it's everything but what's in circle A. So all of the outside. Okay, so what I want to do is take this and remove that from it. Okay, so if I remove that from it, then what's left shaded? Okay, so we're taking everything that's shaded, except for circle A, we're removing from that B and C. Okay, so what's left? Just everything outside of all 3 circles, right? It's just everything outside. So none of the circles are shaded. Okay, so everything outside of the 3 circles, right? Because that's all this shaded area, and from that we're getting rid of this and this, right? So all that's left is everything outside that. Okay, so there, we'll stop there.